Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google, and today we're going to talk about taking your ASP.NET apps to the next level with Google Cloud. Before I start my talk, I have some books, Google Cloud for .NET developers here. So if you're interested, stop by after my talk, and I'll be happy to give these away. Um, and then a little bit of information about myself. Oh, this doesn't work. Good. So this is this is my Twitter, my email, and my blog. If you have any questions about any of the stuff I say today, feel free to reach out to me. As I mentioned, I'm a developer advocate. I'm based in London, but it's always great to be here. By the way, we also have Twitter handles, Windows on GCP. So we're going to be tweeting about Windows and .NET on Google Cloud from this hashtag. And I'm going to also share my presentation with you on Windows on GCP and Google Next hashtags. So you don't have to take pictures if you don't want to. I'll share my presentation. All right. So first of all, it's a great time to be a .NET developer. For years and years and years. By the way, who is .NET developer here? Great. Yes. So you know what I'm talking about. For years and years, we've been constrained to Windows world. We had all this good stuff with C#, Visual Studio, PowerShell, SQL Server, and it was frustrating for me to just do that on Windows because I had to do stuff on Linux once in a while, and I had to switch my tools, switch my databases, all that kind of stuff. But now with ASP.NET Core, you can target Linux with SQL Server now runs on Linux, PowerShell runs on Linux, Bash from Linux runs on Windows. So it is truly a great time to be a .NET developer. And at Google, we are trying to help with this revolution with Google Cloud. So this talk is about that, basically. I just want to show you what kind of stuff we are doing to help with .NET developers running on Google Cloud. So the agenda today is first, I like to start my presentation with answering why first before I show you how. So the why here is that, why should you even care about Google Cloud when it comes to .NET development? So I want to go through that, make sure that it's crystal clear to you guys why you should even care about Google Cloud when it comes to .NET development. Once we answer that question, I want to talk about moving your existing .NET apps to Google Cloud. So I'm going to show you a simple app running on my laptop, and then we're going to look at how you can take that app and move to Google Cloud. So the point here is to show you how easy it is, basically, to have what you have today and move it. Once we do that, once you have your app running in the cloud, you have all these services and all these tools that become available to you. So we're going to take our application to the next level. We're going to use cloud storage, we're going to use PowerShell commandlets, we're going to use Visual Studio plugin, we're going to use machine learning with Vision API and Speech API, and just show you how easy it is, once you have your app running in the cloud, to basically enhance your application with the services that Google Cloud provides. And then finally, it's fun to work on fun features, but then you need to make your application production ready. So you need to have logging, you need to have error reporting, you need to have auto-scaling, you need to have load balancing. These are boring tasks, but everyone has to do it. So I just want to show you what kind of tools we provide to make that easier for you. So this is the agenda. So let's just answer the question first. The first question that you probably have is, Windows Server, SQL Server, ASP.NET on Google Cloud, what's happening, right? Because Google is known for many things, like Google is known for machine learning, Google is known for search, Google is known for Java and Python. We supported Java and Python for a long time on App Engine. We invented Go, and Go is really popular now. So when you think about .NET and C#, you don't really think about Google Cloud up until recently. And I think you're right to think that way, because if you look at the world that we lived in up until 2014, it kind of looked like this. So on one side, we had the Linux world, the open source world, and the tools around it. So for languages, we had Java, Python. We had Apache projects. We had Eclipse, IntelliJ as IDE. We had MySQL as your SQL server. You had Bash for scripting. And there were a bunch of other tools here. I'm just simplifying a little bit. And then parallel to that, we had the Windows world. Now, with the Windows world, you had similar things. So instead of Java, you had C#. Instead of Bash, you had PowerShell. Instead of MySQL, you had SQL Server, and so on and so forth. And the unfortunate thing was that these two worlds, they existed side by side, but they never really interacted. And that was really frustrating for me because I started my career as a Windows developer. I learned all these tools. And then at some point, I had to switch my job. So I moved to Linux world. I had to relearn everything. And you could argue which side is better. You know, I have my own opinions. Like, for example, I think C# is much better than Java, for sure. But that's not the point. The point is that you were trying to solve similar problems with almost similar tools, but they were slightly different enough to make it annoying for you, right? But things are changing. If you look at what happened in the last couple of years, it's almost like a revolution. So first, .NET went open source in 2014. That was big news. And then we gradually started seeing tools moving from Windows to Linux and from Linux to Windows. Like, for example, OpenSSH moved from Linux to Windows, so you could run that on Windows. Then we had like Ubuntu and Debian running on Azure. After that, in 2016, it was probably the biggest year for .NET and Windows. We had the flagship SQL Server now runs on Linux. I mean, if you think about that, like 3 or 4 years ago, you couldn't even think about that, and now it runs on Linux. Similarly with PowerShell, the PowerShell commandlets, they run on Linux. And then stuff also moving from Linux. So Bash now runs on Windows. And lastly, not lastly, but ASP.NET Core is the most exciting part for me. So now you can write your ASP.NET apps and target Linux, Windows, and Mac. And that is really exciting. And actually, there's a talk today, later at 2:40, on .NET containers that will cover this. At the end of my session, I'm also going to point you to all the other talks and all the other sessions that we have on .NET and Windows, so you know what we have. And then finally, the year ended with 2 announcements. The first one was Microsoft joins Linux Foundation, and then Google joins .NET Foundation. I think that was, for me, that was kind of like the highlight of the year. So now, when you look at the world that we're living today, we still have these 2 worlds. So we still have 2 operating systems. But then the tools and languages around them, they are much more converged. And this is really good news for us because all the time and effort we spend in learning C#, learning ASP.NET, learning PowerShell, all that kind of stuff, now we can apply them to Linux. And that's great news. All right. So now let's talk about what Google Cloud is doing to help for this. But before I do that, let's answer the why question first. So why should you even deploy to Google Cloud? And let's look at this question from a consumer perspective. So let's say you're a cloud consumer, you're shopping around, and Google Cloud tells you that you should deploy here. Why should you do that? There are many reasons, but I think in my mind it boils down to 3 main reasons. The first is Google's infrastructure. So when you're running your application on Google's cloud, you're basically running on the same infrastructure that Google is running, which means that you're running on a private network, even between data centers. So if you go from one data center to another data center, you're going through Google's own private network, which means that you have good latency, good throughput, and it's very stable. So we have fast VM provisioning. So if you want a VM, it becomes available to you within seconds. And that's really important because when you're moving applications to the cloud, you want things to be elastic, so you want to get VMs as fast as possible. And also autoscale. Autoscale is also really important. When you have lots of load, you want autoscale to kick in to add more machines. And when the load is gone, you want to scale down to save money. So the autoscaling at Google Cloud, because of the network and because of fast VM provisioning, it really works really fast, and it really helps for scaling up and scaling down. So that's number 1. Number 2 is price. So if you're shopping for something, you definitely care about price. So what we try to do is, first of all, we try to keep our prices as competitive as possible. But on top of that, we have features that help you to save even more. So for example, if you want to run your VM for 10 minutes, you pay for 10 minutes. You don't pay for the whole hour. If you use your VM for the whole month, you get automatic discount up to 30%, and you don't have to do anything about that. We just detect that you run the VM for the whole month, and we give you a discount right away. If you have a VM that's with lots of CPU and memory, but you're not really using that, we detect your load and let you know, and we tell you, by the way, you can scale this VM down. You can decrease the memory, you can decrease the CPU, and run it cheaper because you don't need it. So we try to detect what you need and tell you how you can save. And then the last part is flexibility. So you can have custom VMs, which means that you can say, I want to have a VM with lots of memory, but not so much CPU, because that's what you need. Or you can say, I want a VM with lots of CPU, but not so much memory. So you customize what you need, and you pay for what you need. So that's great. And also, in situations where you have like a work queue, we have a queue of work, and you want to have VMs, just working from the queue, we have something called preemptible VMs. These are VMs that can come and go depending on the load in other parts of Google Cloud. But the good thing about them is they're perfect for this work queue situation, where you can just have 20 of them or 25 of them. It doesn't really matter. But they're all up to 80% cheaper than the regular VMs. So these all combined, I think, is a compelling reason why you should care about Google Cloud as a consumer. But as a developer, we are almost all of us are developers here. What's in it for you? So let's look at that from a developer's perspective. So the first thing, again, is deployment options. If you want to run your app in a VM, we have Compute Engine. If you switch to containers and you want to have your container cluster, we have Container Engine. If you don't care about containers or VMs and you just want to deploy your app and let someone else take care of scaling it for you, then you have App Engine. If you don't even care about apps and you just want to write your functions that gets triggered by some trigger, then you have Cloud Functions. So no matter what you want to do, at what level, we have options for you, all right? The second thing is managed services. So once you have your app running in the cloud, there's all these services that becomes available to you right away. And the key thing about these services that we try to do is we try to make them as managed as possible. By that, I mean, for example, take PubSub as an example. PubSub is a publish subscribe messaging framework. So you create a topic, and then you push messages to that topic, and then you get messages from that topic. Normally, if you set up a cluster or PubSub, you need to worry about machines, you need to worry about how you're going to globally distribute that queue and stuff like that. Whereas in Google, PubSub basically you just create the topic, and all of the infrastructure is abstracted away from you. You don't care about how many machines it's running on, or you don't care where it's running. It's globally scaled for you automatically. So this is true for BigQuery, this is true for Bigtable. So we try to make it as DevOps-less as possible for you. And then finally, most importantly, in my mind, is machine learning. So machine learning is really big at Google. We use it in most of our products. And we have all these models built up using the data that we have. And now we are providing this machine learning to you through APIs. So we have Vision API, we have Natural Language Processing API, we have Speech API. So we try to basically make it really easy for you to consume machine learning from your apps. And I'm actually going to show you in the demo an example of how to do that. And if you want to build your own machine learning models, you can run TensorFlow at scale using Google Cloud Machine Learning. All right. So the last thing that I wanted to talk about before I show you code and demos is what options do you have as an ASP.NET developer when you want to deploy to Google Cloud. So if you are a traditional ASP.NET person, your app is running in ASP.NET on Windows, you can take that and you can host that on Compute Engine, and it's good to go. So it's running in Compute Engine in a VM in Google Cloud. And the sample that I'm going to show today is going to show how to do this. And then if you made the switch from ASP.NET to ASP.NET Core running on Linux, then you have more choice. You can run it on App Engine Flexible Environment, or you can run it on Container Engine. So in App Engine Flexible Environment, you basically take your ASP.NET Core app, put it in a Docker container, and just say to App Engine, just take this container and run it for me at scale. So App Engine kind of figures out what kind of scale do you need, and it provisions machines, and it load balances, and it has versioning, and it has traffic splitting. So it has all this goodness built in. All you need to do is just wrap your application into a Docker container and just give it to it, and it will just run it at scale. It's very easy. And the session in this afternoon will show this App Engine Flexible Environment later. If you want to build your own container cluster, you can also wrap your ASP.NET Core application into a container and run it on Kubernetes in Container Engine. So this gives you more flexibility. It's more involved than App Engine. But with that, you have more flexibility of what you can run in your container cluster. So this is for the app side. So for data, if you're using SQL Server, you can take that SQL Server and run on Compute Engine, and we support all the versions from 2008 till 2016. And then we have tools. So we have a Visual Studio plugin where you can manage your Google Cloud resources from Visual Studio. We have lots of .NET libraries to talk to pretty much all Google Cloud services. And then finally, we have PowerShell commandlets that lets you script your access using PowerShell. So no matter what you want to do, ASP.NET, ASP.NET Core, SQL Server, tools, we try to basically make that available to you. And there's more and more stuff that are coming. So yeah. So that was enough talk. Now it's time to show you some code and some demos. So in this part of the talk, I want to show you a simple application. First, we're going to run it on my laptop. And then once it's working on my laptop, I want to show you how you can take that application and move it to Google Cloud. The application that I want to show you, it's called Contoso University. Maybe some of you know this application. Anyone knows? No? Maybe. OK. So Contoso University, it's a fictitious university. It's a reference application for ASP.NET MVC5. So it has like some simple pages for students, for courses, for instructors, and it's backed by a SQL Server instance, and it's using MVC, so Model View Controller 5. So it's just a reference application showing how to use MVC backed by a SQL Server. So let's just take a look at that quickly. So in the demo, I just want to show you how this works locally on my machine. So I already have the Contoso University solution open on my machine. And as I mentioned, this is an MVC application. Well, I already have it running, so let me just show you that quickly here. So this is running locally on my machine. If you go to students, this is showing the students. It's paged. You can look at the details of the student. We have courses. And then we have instructors. So it's pretty basic. And then just to show you code a little bit. So we have, let's start with models. So we have models for student, course, department. If we look at the person, for example, this has last name, first name, full name, and then student extends from the person, and on top of that, it adds like enrollment date, enrollment, so you know which student belongs to which class, stuff like that. As you know, in MVC applications, you have a controller that actually controls the model. So let's look at the student controller. So in student controller, we have like basic methods for HTTP calls. So for example, if you get a detail of a student, then this method gets called with an ID. And then we have a DB, database object. And then from there, we find a student. And then we just return the view. And then we have a bunch of other methods for creating a student, editing a student, so on and so forth. So we covered model, we covered controller, and then we have views. So if you look at the views folder, we have separate views for a bunch of different things like courses, departments, home. But then if you look at the student one, it's basically just HTML. Let's look at the details page, for example. It's basically HTML with some ASP.NET stuff scattered in there. All right? And then one last thing to show you is web.config. Oh, sorry, here. So in web.config, there's a local DB. Yeah. So the actual database is local. So it's the SQL Server running locally on my machine. But we're going to change that later to use a SQL Server running in Google Cloud. OK, so this is the app. Let me just go back to my presentation quickly. All right, so now I want to take this app running locally, and I want to push it to Google Cloud. So let's see what steps I need to do that. First, I'm going to make life easy for myself, and I'm going to install Google Cloud Tools for Visual Studio. This will enable me to interface with Google Cloud, create VMs, and stuff like that. Once I have that, This is a traditional ASP.NET app, so I need a Windows VM with ASP.NET Framework already installed on it, right? So I'm going to use Visual Studio plugin to get a VM that I need. We also need a SQL Server instance because the one that I'm using right now is local. So I'm going to get a SQL Server instance on Compute Engine. And then finally, I'm going to publish directly from Visual Studio. So from Visual Studio, I'm just going to publish to the VM that I just created. So these are the steps. So let's just take a look. So in this part, I'm going to first let me stop this. So if you go to Tools and then Extensions and Updates, this is where you can install Visual Studio plugin that we have for Google Cloud. So I'll go here. I click on Online. This searches Visual Studio Gallery. So here, I'm just going to type Google Cloud. And as you can see, this is the extension I want. It's already installed for me because I have it here. But if it's not, you can double-click and it will install it right here. And you need to restart Visual Studio. So once you do that, you go to Tools, and then you see this Google Cloud tool. So this is the plugin that basically lets you access Google Cloud. First, you need to add your account so that Visual Studio is authenticated with Google Cloud. You go to Accounts, and then Add Account. This opens a new browser, and it tells me, it asks me, which account do you want to use? I want to use my development account. And then Allow. And now Visual Studio is authorized to access my account, which is great. I go back here. It tells me that your account is already here because I already added my account here. That's OK. And now, if I go to Tools and Google Cloud Tools, I do show Google Cloud Explorer. Now, this is me. And then these are my projects that I have under my account. I'm going to look at the .NET project that I have. Under here, I can see all the VM instances that I have, all the storage and SQL. So there's going to be more stuff here added. It's coming up. But for now, we just show Compute Engine, Cloud Storage, Cloud SQL. But in the future, you basically will be able to see all your resources from here. So what I need to do here is first, as I told you, I need a Windows VM with ASP.NET Framework. So let's try to get that. What I'm going to do is I'm going to right-click here and just say New ASP.NET Instance. And this takes me to Google Cloud Console. And then there's something called Cloud Launcher, which is like a marketplace for solutions on Google Cloud. And one of those solutions is called ASP.NET Framework. So this will enable me to install get a Windows VM with ASP.NET Framework with basically one click. So I'm just going to say Launch on Compute Engine. And then let's just call this ASP.NET GCP Next San Francisco. You can choose your zone. Let's just choose US West. You can customize your machine type. You have like 2008, 2012, 2016. I'll choose 2016. And then you can customize your disk size, all that kind of stuff. And then I just hit deploy. And now, within a couple of minutes, this will give me a Windows VM with ASP.NET Framework installed. Now, I already have one. So let me just show you that quickly. If I go on the Compute Engine, I already have this Contoso original as my VM. So you can actually RDP into that. So let's do that. And I will enter my credentials. And I just RDP'd into the Windows VM server that I got ready before this talk. These VMs, they already have Cloud SDK installed. And they have Server Manager. So it's just a regular VM running in the cloud. All right? The second thing I need, so this will go on for a little bit, but we'll use this one for now. The second thing that I need is a SQL Server. To get SQL Server in the cloud, what I need to do is now right-click on Compute Engine again. But instead of ASP.NET Instance, I'm going to just say New Instance. So this is going to be a little bit different. And it takes me to the right place again in Google Cloud Console. And what I'm going to do is I'm going to call this Instance SQL Server GCP Next. And then I'll choose my zone to US West. And then the boot disk, right now it's pointing to a Linux instance. I don't want a Linux instance. I want a SQL Server instance. So under here, you can see all the OS images, including Windows images here. but what I want is application. And then under here, you have all the SQL Server instances. So I'm just going to choose, let's say, SQL Server 2016 standard, and then hit select. And then I can just keep the default create. So with this, I'm going to get a SQL Server within a couple of minutes running in the cloud. Again, I deployed this SQL Server before, and I configured it already. So let me just log in and show you quickly how that looks. All right. So the SQL Server instances, by default, they come with SQL Server Management Studio. So I'm in the VM right now, and as you can see, this is my SQL Server instance, and these are the databases that I created for this demo. So it's pretty standard, like the stuff that you get used to, but they're now running in the cloud. All right, so that's good. Let me get out of here. Now what I want to do is I basically want to take my app and deploy it to the cloud now, right? First thing I need to do is, let's go back to Visual Studio. Let's close this. I need to change web.config to point to the SQL Server that's running in the cloud instead of the local DB one. So what I'm going to do is I'm going to comment this out. And then I'm going to add this in. So this is the IP is the IP of the SQL Server instance that I already have running, and I already created a user and a database there. So I'm just using that. So that's number one. And second thing is I need to tell Visual Studio how to publish this application to cloud. So to do that, I need the publish settings file. So I'm going to go to Tools and show Cloud Explorer. So this is the VM that I want to publish to. So I'm just going to right-click and say Save Publish Settings. And let's just save it to desktop. So it's saved. And then I'm going to right-click on this app and then Publish. And what I'm going to do is I'm going to just import the publish settings that I just downloaded. Let's just point to there. Desktop, and it was this one. Okay. So as you can see, all the IP details and username and password, they're already filled for me. Let's just validate, make sure that I have the connection. It's green, that's good. I'm just going to check this guy and then hit publish. Now it will wrap up my application, and then it will just publish to the VM running in Google Cloud. And it should just take a couple of seconds. Publish succeeded. And if we go here, and then I click on the external IP, it's the same application. And if we go to students, it's the same application, but it's running in the cloud and talking to a SQL Server also running in the cloud. So that's what it takes, basically, to take your application and publish to Google Cloud. So I'll go back to my presentation. Let's do it at the end. All right. So we moved our application to Google Cloud. Now I want to take it to the next level. So what I want to do is, first, the students, they don't have any pictures, right? So I want to add some profile pictures for students. But you need a space to save them. So I'm going to use Google Cloud Storage for that. So I'm going to use Google Cloud Storage, create a bucket there, and save the pictures there. But saving pictures for every single student is going to take a long time, one by one, especially if you have a big university. So thankfully, we have PowerShell commandlets that you can basically use to script things. So what I'm going to do is I'm going to use PowerShell commandlet and move the pictures to the bucket I want using the commandlet. Then, students can be funny. Like, they can upload any kind of pictures. So maybe they'll try to upload like violent pictures or adult pictures, and I want to prevent that from happening. So what I'm going to do is there's this machine learning API called Vision API. You can give it an image, and it gives you annotations about that image. So everything it knows about that image. And we're going to use that Vision API to detect if an image is violent or adult image or something like that, and prevent that student from uploading that image. And then finally, I want to add some fun facts about the student, so something interesting about the student. But I want to make this so that the student can speak, and we will detect from their voice, and we will convert that to text, and then we will enter that as fun facts. Doing this on your own, it's not that easy, but I can use something called Speech API. It's another machine learning API, where you can basically pass in a file with some sound, and then it extracts the text for you. So that's what I want to add to my application. So let's take a look at our code again. All right, so what I'm going to show you is, first, let's look at the profile picture. So let me just find the code for that. All right, first I created a service, and I called it image uploader. So this is a really simple service. Let's see if you can see that properly. So this service, one thing you're going to note is that it's using Google Cloud Storage. This is a NuGet library that you can reference from your application. And with that, you get access to cloud storage. And this image uploader, it basically takes in a bucket name, because in cloud storage, you need to have a bucket to save images. And then it creates a storage client. So this is the guy that we're going to use to talk to cloud storage. And then it has two methods. One method is called upload image, and the other one is called delete image, because when you delete the student, you want to delete the image as well. So the upload image is, it takes in an image, and it takes in an ID. So this is the ID of the student. And it uses cloud storage to upload the image. And it basically just says, take this image, save it to this bucket with this ID, and then this is the source, and make sure that the image is publicly readable. So with one call, you can basically upload the image to cloud storage. And then if you look at the delete uploaded image, it takes in an ID, and then uses storage client to delete the image. So it's very basic. And what I also changed is that if you look at student controller, I added an image uploader, and I'm going to talk about the safe image uploader in a little bit. And then if you look here, for example, this is the create method. This is when the student is created. What we are doing is, if an image has been passed, then use image uploader to upload that image with the student ID, and then this will return you a path. It's a public URL, basically, and then we'll set that as the student image path. All right? So with that, we can have profile pictures. So let me just show you how this works. This is the one. So I have it running locally already. I'll go to students, and let's just create a new student. And I'll just add myself as a student. I'll talk about fun facts afterwards, but let's just choose a picture. I'll choose one of my pictures. And then let me just change this to 2017. Hit create. So this will basically take my picture, upload it to cloud storage, and then save it as image path. And if I look at the student list, I am here. And if I look at the details, I have a picture. Great. OK, that's good. But having these pictures for each student and uploading them one by one, it's going to take a while, right? So what I want to do now is I want to use PowerShell commandlets that we have to script this, so that we can upload a bunch of images all at once. When you install Google Cloud SDK, you have these commandlets by default. So you have them by default. So I have it here already. So let me just show you this PowerShell commandlet. So it's called upload pictures, and then it also has a pictures folder right next to it. So what we're doing here is that I have a bucket. So this is the bucket that I want to save in cloud storage. And this is my folder of pictures. And all I'm saying is that new GCS object. So GCS stands for Google Cloud Storage. So basically, what this command does is that take this folder and upload to this bucket and make sure that they are publicly readable. And then I do this by new GCS object, and then basically just run this. And let's just do that, see how that looks. So as this is working, in here, I can show you there's a bunch of other commandlets, like add GCS bucket, add GCS object. So these are all Google Cloud PowerShell commandlets that you can use in your scripting. As you can see, it's already looking at the images and uploading them. And if we go back to our console, and I go to here and cloud storage, I have a bunch of buckets for all my projects, but the one I care about is called Contoso. I click here, and you can see that the folder is already uploaded with a bunch of pictures, and I can use these pictures, change my code so that they can refer to these pictures and just use them. All right? So the next thing I want to show you is, so these pictures can be anything right now. So a student can upload any kind of picture, and we want to prevent that. We want to make sure that these pictures are not violent, they're not adult pictures. So to do that, I want to use Vision API. So let me go back to code again. What I did is I created another service called Image Safety Checker. So this guy, come on. Yeah. All right, this guy, it's using the Vision API library. So it's a NuGet package again that you can install. And then it has a client again called Image Annotator Client. So this is the client that you use to talk to Vision API. So when we create this image safety checker, we create the client as well. And then it has a simple method called isSafe. So given a file, this takes the file and then passes it to the image annotator client right here. And then this basically calls Vision API and gets some annotations about that image, okay? And then the annotations, they have 4 dimensions: adult, violent, spoof, or medical. So what I'm doing here is that, and these annotations, they're enums. So they can change from very unlikely to unlikely, possible, likely, or very unlikely, okay? So given an image, it basically tells you this image is very likely that it's an adult image or very unlikely that it's a violent image, stuff like that. So what I'm doing here is that I'm basically just checking all the dimensions and making sure that their likelihood is less than possible, so that it's not possible that they're adult or violence. So this method will basically give me the safety that I need. And then what I did is that, remember we had the image uploader to upload our images? I created another one called Safe Image Uploader, and it extends from Image Uploader. And then the only thing that it adds is that it basically has a reference to this image safety checker. And when we upload the image, instead of uploading that image right away, we call the image safety checker and ask, is this image safe? If it's not safe, we throw an exception, and then otherwise we just upload the image. So with this, I have the safety that I need to upload my image. And then if we go to student controller, I showed you before, instead of creating a regular image uploader, I'm creating a safe image uploader. So by default, I'm using this safety feature. And let me just show you how that works. So go back to my app. I think it was this one. So let me edit this. And then let me just choose another image, this one. This is like a guy shooting, so it's kind of violent, I guess. So let's see if we can stop this from being uploaded. So I choose that, hit save. And then it says, oh, unable to save changes, blah, blah, blah. Because I had that exception, because of the exception, I cannot upload the image. So it's pretty easy. And then the last thing I want to show you is the fun facts. So as you can see, there are some fun facts here that you can add some text about the student. What I want to do is like have this record button. You can click on it and talk to it, and it will detect your voice, convert it to text, and then edit here. So to do that, what I did is I created a couple more services. So the first one is called Voice Recorder. So this is not that interesting. It basically has a method called record from microphone with seconds. So you provide some seconds, like say 3 seconds, and it records your voice from microphone for 3 seconds, and it saves it to a file. That's all it does. So there's nothing fancy here. But then the other one, Voice Recognizer, it's much more interesting. First, it's using the Google Cloud Speech library. And then it has something called Speech Client. So as you can see, all the services that we have, they have the same pattern. They have a NuGet package, and then they have a client that you create, and then you use that client to talk to it. So in this case, it's the speech client, and then it has a method called recognize. So what it does is that it basically just, using the speech client, it calls recognize async, and pass in some parameters that are usually the default ones, and then you provide a file path, so the file path of your recording. And then this gets sent to the speech API in Google Cloud, and that returns some results. So usually when you pass in your voice, you have one result back, and you can just use that. But sometimes, depending on how clear your voice is, you might have multiple results with multiple alternatives. And each alternative has its own confidence level. So you would look at the alternatives and pick the one that has the highest confidence. But in this case, I'm just looking at the first alternative and just returning the first one, because this is just a demo. All right, that's good. And then what I lastly changed is in student controller, I created a new method called record. So when you click the button, it gets called here with the student ID. I find the student, and then I use the voice recorder to record my voice for 3 seconds. That saves to a file. Then I pass that file to voice recognizer that I just wrote, and just say recognize. And that gives me from the voice the text. I get the text back, and then I just set that as the fun facts of the student. Okay? So let's try this out. So here, I'm just going to say something. Let's see if it works. He is cool. Oh, I don't know it worked. Okay, I'll try one more time. Maybe the microphone is not hooked in, but he is cool. Ah, yeah, it worked. Cool. So hit save, and that's it. All right. So I'll go back to my presentation. And let's see, I have some time left. So this is fun. As you can see, we moved our application to the cloud. And with that, we got all the services almost for free. And then with a couple of lines of code, we use machine learning to detect images, if they're bad images. And then we did speech to text. But now you need to take your application to the production, right? We have some problems with this application. For example, first of all, this application just runs on one VM in the cloud. If that VM goes down, you have no way of knowing that. So what you actually need is health checks. You need to add health checks to make sure that you know if your application is healthy or not. There's no logging right now, so you're kind of blind. Thankfully, there's something called Stackdriver logging in Google Cloud that gives you centralized logging, not just in Google Cloud, but across other cloud providers as well. So we'll add Stackdriver logging to our application. There's no error reporting, so if there's an error, we don't know about that, there's something called Stackdriver error reporting that basically captures all the errors in your application and then gives you a centralized dashboard to look at all your errors, when they happened, how often they happen, stuff like that. So we'll add that. And then our application is not resilient because it's just one instance. If we have more load coming in, one instance is not going to cover that. We need multiple instances, load balanced, and we need auto-scaling, actually, to make this work. Thankfully, there's something called instance groups in Google Cloud that makes this really easy. So we're going to add an instance group and have all of this happen magically for us. So just to talk about the scaling in Google Cloud, so this is what we had initially. I had my application running locally. Then I pushed it to a single VM running in Google Cloud. So what you can do from that point on is that you can take that VM and create a snapshot out of it. It's called an instance image. So this is kind of like the snapshot of your application. And then from the image, you create an instance template. So template is like a blueprint for your application. It's a way of, it's a blueprint of how you can create the same app on a different VM. So once you have the instance template, From there, you can create an instance group. And this is where all the magic happens. Basically, with instance group, you get multiple VMs, load balance behind a load balancer, and they have health checks. So the load balancer uses the health check to check your app. And then it also has auto-scaling. So if you need to have more than one instance, it will automatically scale. So the instance group basically gives you all the stuff that you need to run your application in production. So this is what we're gonna, I'm just gonna show you quickly what are the steps for you to set this up. All right, so let me first show you the health check. First, for the health check, I created a new controller called ping controller. So this ping controller, it's very simple right now. It basically, when you hit the endpoint, you get a pong back. Normally, in a real-world application, you want to check your dependencies and make sure that they're healthy before you can return OK. But in this case, I'm just returning OK no matter what. I also created another endpoint with some ID, and I'm just throwing an error because I want to show you how this works in Google Cloud stack driver error reporting. So I have this ping controller, and actually, if I go back to my app, I think it was this one. And if I do API/ping, yeah, it just tells me pong, nothing interesting. But what you can do is you can go to Google Cloud Console, and under Compute Engine, and then health checks, you can create a health check. I already have one, but let me just show you how that health check looks like. You basically just say, this is an HTTP health check with port 80, and this is the endpoint that I want to hit to make sure that it's healthy. And then these are the criteria for my health check. So I'm going to check every 30 seconds, and if I get OK 2 times, I'm going to assume that it's healthy. If I get errors 2 times, I'm going to assume that it's not healthy, stuff like that. So what we're going to do is we're going to use this health check to create our instance group. And then when the load balancer gets created with the instance group, it will use this health check to determine whether our instance is healthy. Okay? So that's one. Let me go here. Second thing I want to show you is stack driver. So let me just find the code. So first, I created something called stack driver logger. So the original logger of the application, it basically just uses trace, but I don't want trace. I want my logs to go to a central place so I can look at them. So with stack driver, all I had to do was, again, use the NuGet package. So this is the NuGet package for stack driver logging. And then from there, I just create a client. Again, it's the same kind of paradigm. You reference the NuGet package, you have a client. So once I have the client, I just use this to log. So by logging with this client, I have my logs central in Google Cloud. So that's number one. The second thing is error reporting. So I want all my errors to be caught and sent to Google Cloud. So to do that, in web API config, I just register stack driver error reporting. So it's basically just one line of code. And all I'm saying here is that when there's an exception, this kind of exception, which is like the main exception class, basically just report that exception to this project, to this service, to this version. So everything that's thrown from my application will be caught and sent to Google Cloud. So let me just show these quickly in the console. So if you go back to console, go to stack driver here. Let's look at the logging first. So stack driver logs a lot of stuff, but in this case, my application is a GCE, a Google Compute Engine instance. So I'm gonna, this is my application, so this is where it's gonna log. And as you can see here, these are my logs. So these are my SQL statements from my app. So it's already going to stack driver because I implemented stack driver logger, and it works. And then to look at the error reporting, I'll go to error reporting. And let's go back to our apps and just hit that endpoint that will throw me an error. So let's just say ping 1. And this threw an exception. Yes, we are here. OK, continue. So this threw an exception. So if we come back here, and I think I need to auto-reload. As you can see, it just says, oh, it just seen this exception. And if it's seen in Contoso application version 1, and if I click on it, I get more details. So I only have it not work today, but if you have it failing like a month, you can see like when it happened, how it happened, what was the stack trace, all that kind of stuff that becomes available to you. But with just one line of code, you can catch all of this, and then it's right here. I think this is really good. And then the last thing I want to show you is the instance groups and auto-scaling, right? So to do that, what I had to do is go to Compute Engine. First, I need to create a snapshot of my application. So I need to create an image. So here I have images, and then as you can see, there's a Contoso GCP one. This is the one that I created. There are instructions on how to create this image, but it's pretty basic, basically. You just go to your Windows VM instance, run a command, and it shuts down, and then from there you just say, create an image from this persistent disk, and you have your image. And you can share that image with other people, with other projects, stuff like that. So once you have this image, then you need to create a template, a blueprint of how to create that image and use it in other VMs. So I have instance templates. So here there's Contoso GCP template that I created before this talk. And this guy, basically, the important thing is that it's using the image I just showed you about. And it has some configuration that you can set. And that's it. There's not much to it. And then you can also specify like what kind of APIs and things that it can use. OK. And that's it. So I have my template. So from this template, now I can create an instance group. So I have 5 minutes left, so I just want to show you that quickly. In instance groups, I created an instance group. And if we just edit that instance group, so this is where all the magic happens. First, it's using the template I created, and then auto-scaling is on. So by just setting this on, I get auto-scaling, which is great. It is using load balancing, so it's HTTP load balancing on port 80. I can specify how many instances I want by default, but minimum. I will have 1 instance by minimum, and then for this demo, I set 3 instances. So it will auto-scale to 3 instances, but you can set that to whatever you want. And then it's also using health check. So it's using the health check that I defined to make sure that my instances are healthy. So with this, I get pretty much everything I want. My application is much more ready to production. And we have all the pieces, basically, to make this happen. So now I want to go back to presentation and just point a couple of things before I finish my talk. So summary, what did we do? We started with an ASP.NET app running locally. We moved it to a Windows server running in the cloud, SQL Server running in the cloud. We added pictures with cloud storage. We added intelligence with Vision API, Speech API. And we made the production ready with like instance groups, load balancing, auto-scaling, stack driver, things like that. But there's much more. So if you go to cloud.google.com/.net/windows, there's much more information. There's a code lab page, but there are also code labs here at Next where you can actually do this stuff hands-on. And I'm going to be there. And if you have any questions, I'll be there as well. Talks at Next. So the first one was my talk, and then we had talk in the afternoon on .NET containers. Another one at SQL Server at the same time. And tomorrow we have a Windows-based talk as well. And tomorrow from 1 to 4 p.m., there's a Meet the Experts area. And I'm going to be there where we're going to have .NET people, basically. So any questions that you have about .NET on Google Cloud, we're going to be there. And as I said at the beginning of my talk, I think it's a great time to be a .NET developer. Thanks for your time. And if you want books, I have books. Yeah, that was it. Thank you.